Are we presenting ABC Map, which is a tool that stands for Adaptation, Biodiversity, and Carbon Mapping Tool. So it's been a collaboration between FAO, IFAD, and funded mainly by the French Development Agency and the German Ministry for Agriculture. The reason why we created the ABC Map tool was to address the three simultaneous crises that the world is facing today. And we did like a lot of progress on biodiversity and climate change, and we are planning this year to develop more of the work on land degradation. And why do you want to do this? We want to do this to support countries and institutions on their reporting for the three Rio Conventions. So we developed ABC Map to be grouped into three sections: adaptation, biodiversity, and carbon. And for each of the sections, we have several indicators. So I'm going to start now with the adaptation section. So in the adaptation section, we have a climatic profile. So we have precipitation, temperature, days of extreme heat, days of frost days, dry days, days with heavy precipitation. And we also have elevation profile and water occurrence and water occurrence transition. So what a percentage of water went from permanent to seasonal to no water, etc. Then on the biodiversity, also this slide I just noticed is outdated. As part of the work we did, the 4 per 1,000, we also have now on the adaptation section the climate risk score that's based on the climate risk toolbox that FAO designed. There's an indicator that shows you how exposed your area is to climate change, and we have that at both the baseline at project level with projections for the different scenarios in the future. I'll show it later during the demo. Then on the biodiversity section, we have a mean species abundance indicator that shows how intact the ecosystem is compared to the original habitat. It ranges from 0 when all the biodiversity in the habitat is lost to 1 when it's intact. We have natural capital that expresses the ecosystem services provided by the area of interest, is expressed in dollars. And this is a work that we are doing with the Foundation for Sustainable Development in the Netherlands, and it accounts for a total of 19 major biomes. We already, to collaboration with AFD, expanded that, and it will be updated this year. We also have key biodiversity areas and protected areas that together can also contribute to as an assessment if an area is of a critical habitat or not. So we map on the map where these areas exist, and we give you like how land use has changed specifically for these areas throughout the years on our baseline assessment. And then we have the carbon section. That is the one that we'll be developing more this year. It's so far, here we have 2 indicators, carbon stock and social value of carbon, and the methodology is based on NEXT. There is the tool that lots of you will be presenting later. These are some of the developments we are doing. We did it like in the past with the collaboration of FD and also the 4 per 1,000. So we developed a new platform. We developed new indicators, and we are still developing some of them currently to be delivered mid this year, like in December of this year, and some others at the end of the year. We are preparing e-learning and training courses. We already have videos on how to use the tools, both in French and English. When we are updating our guidelines for this new version. And once they are updated, we also publish them in French. So ABC Map has been designed for project ideation and project design phases. So it's a tool that, as we will see, it's very easy to use and you get results very quickly. So as the first step on your project ideation, you're going to get an idea of the current status of the land, of the area of interest, and what's the expected impact of your project. And that's very easy to change, go back and change a few criteria, a few parameters, and see how that changes the expected impact. It can also be used for early phases of monitoring and evaluation, considering how easy it is to draw an area on the map and see how the different indicators have changed throughout the year. And we are planning on expanding the capabilities to be able to assist at country planning and strategies, so that you can draw like large areas or like at a country level and say how much land you want to convert from one type of land management to others, and then get an assessment of the expected impacts at a country level, which is something that's still being developed. So I will go now to the demo. Let me just. So ABC Map is web-based. Like right now we have English and French. Very soon we also have Spanish. We have a meeting with a Spanish team next week, so we're hoping to get it ready by then. You just click on open. If you want to have more information, like detailed information about all the indicators that I mentioned, you can just go to guidelines and download the PDF from the FAO website. It has like all the formulas, all the data sets that are being used, how they are being used. We are in the process right now of updating that to the new interface. So the methodology, the formulas, they are all the same, but the interface there is still the old one. And this is how ABC Map looks once you start. The entry point is just to identify an area of interest. So this is the area for which you want to measure the impact of your project. In this case, I'm going to upload a shapefile. So this area, yeah, this is the one. So you get the shapefile on the map. You can change the resolution or the discount rate. So the discount rate is going to impact the monetary values. So if you don't want the default monetary values we have for the ecosystem services or the social value of carbon, if you want to change them for any reason, like you believe that they are not accurate for this country, or you think like the data sets that you used do not reflect your expectations for how the social value of carbon are going to change, so you can change them here. And after you do that, you just click next, and then ABC Map starts calculating all the indicators I mentioned using Google Earth Engine through the collaboration we have with Google. We are using it in real time, so that it's calculating it right now. So we already get the result for the climate risk tool. So we can see that has like a moderate risk as like based on past trends and observed data with a score of 1. And you can get more details and run more detailed analysis of why we're getting this score by going to the climate risk toolbox website if you want to. We get the climograph that's showing like the dry season and the temperatures throughout the year for this region. We have the mean annual temperature. All the charts can be magnified and also right now is not available, but we are working on making the data downloadable, but you can over the chart and see the exact values. And we also have extreme precipitation per year. You can see there's been a trend of like an increasing trend of days with heavy precipitation. We have dry days per year, which has been like decreasing, like the amount of days with no precipitation at all. I mean, we are in the very close to the equator, I believe. I don't remember the area exactly, but it's so no frost days in this area. We can see the elevation profile, like the percentage of area with elevation around 350. This is most of the area of this area of interest is around 300 and 300 and 400 meters of elevation. You can also see the average here. You can see the maximum and the minimum elevation. We can see how water is changing. So most of the water that occurs in this area of interest is permanent, staying permanent. But in the second is seasonal, and the third one is new seasonal. So it's new places where there was no water, and now there's seasonal water because maybe the irrigation lake or dam was like built in the area. Then we can also see how the slope is distributed in this area. Most of these areas like gentle slope or moderate slopes. So it's like a not very rough terrain. Then we have the indicators for biodiversity. So we can see based on the European Space Agency land cover CCI, how the land use has been progressing throughout the years. So there was like a slight increase in cropland, but then for the most part has been remaining stable. And we can see that the mean species abundance has an aggregate score of 0.3, so like 30% of the score. And we can see the biggest pressure. So this is a bit counterintuitive, but the lowest the value here, the more it contributes to the aggregate. So it means like having a low score on the land use it's contributing to a lower score on the aggregate. So it means that most of the pressures for a low value in biodiversity are coming from the land uses for this area of interest. And we can see that the mean species abundance follows more or less the same trend of increasing cropland. So it slightly decreases the mean species abundance. It's not the only factor, but it's the main factor in our models that affect the mean species abundance. And then we have the same for the natural capital. So we can see by having some transitions on the land use and how that affects natural capital, that has a slight decrease, but for the most part remains stable. And then what we can also do is we can also go and see like for key biodiversity areas that we can identify on the map. Here they are. So the one now there is considered a key biodiversity area. And we can see for this area specifically how the land use has changed. We can see there have been also changes in the key biodiversity area, decreasing forest and increasing cropland, but there have been some efforts in the past, like in the recent past, to correct for that. And we can do the same for protected areas. We can see within these also protected areas that coincide with the key biodiversity areas. So there's like an overlap. And we can see that also within the protected areas, there was a decrease from grassland to forest, probably from the same efforts of the restoration that happened there. And then going down to the carbon section, we can see there's been a decrease of total carbon stock, likely from the deforestation. And there was a slight decrease of the trend in the social value of carbon. The reason why it continues to grow is because over time, the World Bank considers that the value of carbon is going to increase. So even though we have a lower amount of carbon stock than we had in 1994, the price is going to be higher. So we can see this growing trend. And then the next step would be to go to objectives. You insert when you're expecting your project to start, when is the last year you want to measure the impact of your project, and we draw plots. Let me just put this back as it's going to help us. So in this case, I'm going to upload also to make it faster. So we have a plot one, I believe, that coincides with the key biodiversity area. So we can see that we try to focus most of the activities within the protected area and key biodiversity area. So we are going to do a reforestation project. So we are going to choose the type of land cover that we are aiming for, the type of management that we are aiming for. So we are aiming for a forest that is not a forest plantation or shrubland, it's a forest, and we are hoping for high integrity as the end result. And ABC map assumes always 100% success rate. We are working also with IFAD to allow for users to change that, but right now, if you wanted to assume like a lower success rate, you would just reduce the area of your implementation to 50%, and it would be not exactly the same of a 50% success rate, but will be very approximate. And we are going to add another polygon. I don't remember exactly this project anymore, but just to show that we can also draw on the map like manually if we don't have the shape files, just going to put a random forest there in the middle. Just for demo purposes. It doesn't reflect any real project at FAO. But if you don't have the polygons of the area, because it's still like in early phases, you can draw polygons freely on the map. And then after you have defined all of the activities you're doing, you have different land management, like land covers and land management options to choose from. We click next. And now we are calculating the same indicators that we had for the baseline, but now with the expected project impact. So it's going to take a few minutes to calculate all of them. So we're already having the climate risk toolbox. That is one of the indicators that we developed for the 4 per mille. we can see that the projections for the 8.5% increase are slightly have a better score than the baseline, but for most of the other scenarios, there's like a decrease of the risk score. Sorry, this is actually worse because it's a higher risk score, and the other ones like have a lower risk score. We can see that we increased from 0.3 to 0.35, so a 5% increase of the mean species abundance by having these two areas reforested. You can see also on the chart that this is the expected increase of mean species abundance. The yellow line staying static is just the last year of observed data, and we just replicate it throughout the project cycle. And the red line is a dynamic baseline. It's on a linear regression from past observations. So this is like if the trend would remain, this is what we expected the MSA to be at the end of the project. This is if there was no intervention, and this is what we expect the MSA to be with the intervention. So we can see that we will increase the area of intact biodiversity by 136 square kilometers, sorry. In the key biodiversity areas, we can see that we did like a full conversion again to forests. So that was the aim of this project, to intervene in the key biodiversity areas to increase, to restore the forest, which is also part of the protected areas. So you can also see in the protected areas the trend of the deforestation stopped, and that we are expecting to have a full forest there. We can also see that the natural capital there was a slight increase in the natural capital compared to what the baseline would be. In this case, $33 million. And we can see there was a slight decrease of cropland to the values that were originally before the conversion of this area. And as a result, we can see also an increase of total carbon stock and social value of carbon. So in very few minutes, we can get all these indicators. And then now, if this is not what I was expecting to my project, I could go back, start again, and very easily, quickly change the land cover management practice that I chose or the areas of intervention and get new results. So this is, we hope and we believe, very useful during project ideation and early phases of project, because now you have data to support your decision. And even though it's based on models and like remote sensing data, it's in the vast majority of cases way better than what project designers or countries or teams have available to make these types of assessment when designing a project. So, and to mention also that you can see the new land cover map on the map. You can see what the areas of mean species abundance are more concentrated. So you can see like a big increase here, and the same for carbon. So in a very short time, this is ABC map. Look, I hope it was more or less clear. I know it's a lot to digest in just a few minutes, but if you have any questions, please go ahead.
Thank you very much, Daniel. Just because you use map that already exist, what is a normal delay? I mean, well, first of all, how you first determine the zone you want to work on? So I guess that this is the same procedure than when you enter the polygon in the second area of the project.
Yeah.
And my second question was, well, a map like that represent I don't know how many hectares, and how long it takes to have all this result arriving to your computer. You will tell me that it depends on your connection, but well, in general.
So this one that I did right now is in real time. So for this area, the amount of time it takes, it's not so much dependent on internet, because it is running the cloud, and the amount of data we have to pass to your computer is not that much. The amount of time will depend on the area. So for very large areas, it can take, I mean, up to 10 minutes, because at 10 minutes we stop the computation and we just report an error to the user and for ourselves, and then we try to see why you're trying to run such a large area. So usually you should get, for the type of projects that we support right now, it should be like 1-2 minutes for the baseline, and then again 1-2 minutes for the project, for the projections, but it can be up to 9 minutes, because that's how much time you're allowing of computational power per session right now. We may change that in the future. We may also try to, we'll definitely try to optimize. For example, we know that's mean species abundance for like large areas. There's some performance improvements that we can do. We focus most of the work we did in the past year to improve the performance of the carbon section, which is the one that you're going to invest more time this year. But we are also working on improving the performance for mean species abundance. But it should take like no more than 9 minutes for each of the phases. And then for how often the maps are updated. So we are heavily dependent now on global maps, land cover maps. That was by design to allow you to run projects having the same underlying data for all of them at global level. So we are using the European Space Agency land cover CCI. I think it's actually now managed by Copernicus. We just got in touch with the team because they have stopped updating it in 2020. So we contact with the team asking for like alternative products or solutions, but they guaranteed us like we are delayed on the delivery, but we are updating it this year. So this year we're going to have like 2021 and 2022 available now in March, April, and then towards the end of the year we should have the 2023 map, and then they will resume a normal delivery, which is at the beginning of a calendar year, they make the map of the previous year available. We are also available. It's not something that you can do on the platform yourself, but it's something that we can support users do if they need to, is to send us, like, if you have a more accurate or more up-to-date land cover map, you can send it to us and we can run the analysis on our side, not using this interface. It's a somewhat complex work, but we can run it with a customized map if you have one. But often it's not the case, especially for 30 years like you have for the land cover CCI, you won't have it for, it's very rare that you find projects with that.
Okay, so thank you, Daniel.